right? So here we have evaluate integral of x cos x dx. This is integration by parts. And what do we do in this case? With integration by parts, you need to know the general formula for integration by parts. So after knowing the general formula for integration by parts, you can go ahead and simplify by comparing the values that we have here. For instance, let's see in our solution. So here we have integral of x cos x dx. Then our general formula for integration by parts is u dv is equal to u v minus integral of du integral of v du. So this is the general formula we can use for integration by parts. Then what do we do? The first one is always x, but then for x is always substituted to be u. So in this case we can say u is equal to, the first one is always x, so u is equal to x. What do we then? The remaining one now will be for dv. After putting x, the next things will be all for dv. Even if there are 20, you all say dv is equal to, and for this case we have our dv is equal to cos x dx. So what do we do in this case? We need to differentiate. As differentiation and integration moves together, wherever there is differentiation, there must be integration. So in this case, we need to differentiate. When we differentiate this one, what do we get? We need to differentiate it with respect to x. So here I'll have du, the x is equal to 1. Then the u is equal to dx. And in this case, again, we need to differentiate this. So dv is equal to cos x dx. We differentiate, we integrate, sorry. So this dv has this, whenever you see the x, just know there must be integration somewhere. And also this dv we need to integrate. So when we integrate dv, we will get v. This d and integral goes. So here I'll have v is equal to, when we integrate cos x, we get sine x. Leave alone about the constant. Let's proceed. So here we can say integral of x cos x dx is equal to, now we can substitute back for these values. Where there's u, we got x.